Hi, I'll be going over the umpire process for minimum characters required to make a string palindromic. So for the understand step, our input is that we're given a string A, and then our output is we just want to find how many minimum characters are needed to be inserted to make the string a palindrome string. It says right here, so return the minimum characters that are needed to be inserted to make the string a palindrome string. So we want to return the minimum number of characters needed to be inserted to make the string a palindrome. So for example, if we're given the string ABC, then our output should be 2. If we're given the string AACECAAAA, our output should also be 2. This is because to make it a palindrome, we only need to insert 2 characters at the beginning of the string. And as it says here, the only operation allowed is to insert characters at the beginning of the string. So in terms of matching, I've definitely worked with palindrome problems before. Typically, I think with what I've learned with palindromes is that we want to use like 2 pointers. But I don't think that'd be the most efficient way. I'm not even sure how the solution will look like with 2 pointers. So I think actually I'll try doing this time is probably like a prefix suffix calculation, and then I'll use the KMP algorithm for this also. So in terms of planning, so I think for this, we want to we want to concatenate like a new string. So let me see. Yeah, so I want to make a new string with a special operator. So I'll make a new string with a special operator, and then as I mentioned before, I'll use concatenation. And then we'll use the KMP algorithm on this new string to find the length of the longest matching prefix of the reverse string, as also a suffix of the original string. So we'll use the KMP algorithm on this new string to find length of longest matching prefix of the reverse string that is also a suffix of the original string. And then we'll just from this we can find the number of insertions required by subtracting the length of the string minus the new length we get from the KMP algorithm. So we use the KMP algorithm, and then we'll subtract the length of the original string minus the length of our longest matching prefix, and that'll give us the number of insertions required, the minimum number of insertions required to get a palindrome. So we'll just subtract length of original string by new string length. Okay. So in order to actually do this, so I think first we'll create that new string, so we can call it something like combined, probably combined. So we'll add the original string, the special operator, right? So we can use something like this, and then we'll add it with the reverse of the original string. And then after doing this, we'll create like an array of zeros, which will help us later with the values of the prefix suffix matches. So we can create, let's say, like new array equals 0 times the length of our combined string. And then we want to use a loop, so we'll loop through our combined string, starting at 1 to its to the end of it, to its end of its length, and then so we can create like a new variable to keep track of the length. So we'll just can call it like length, and then we'll have it equal the last element in our new array, the value of the last element of our new array. And then while this variable is greater than 0, and the value we're iterating over doesn't equal the value of our length that we're looking at, which is the last element in the array. So so while length is greater than 0, and then while the element that we're currently looking at, that we're iterating over, it isn't equal to our length. We'll have length equal our new array element, but the last but our length minus 1. So we'll just do length minus 1. Then we'll just have our new array element equal length, and then we can get the length of our longest palindromic suffix through our new array. So our longest palindromic suffix length will be equal to the last element in our new array. think that should be good. And then after the loop ends, we just want to check. So if the length of our longest palindromic suffix is equal to the length of our input string, then we just want to return 0. Oops. Otherwise, if that case doesn't pass, then the length of our input string minus our longest palindromic suffix length should give us the minimum number of characters that would need to be inserted to the original string to create a palindrome. Okay, so I'll run it and let's see. I must have typed something wrong. The reference before assignment. Did I write it differently? Let's see what line is it. Line A. Oh, I should forgot something, but I don't know if this will fix it, but I don't think it will, but it's a runtime error, but I forgot to increase the length, so we want to check if iterating over equals what we have in the array for the length. And if it is, then we just want to increase length. Let's see, I'll try running again. Unbound local variable. So line reference before assignment. Must be doing this at the end of the loop. Otherwise, we can't use it. So that's probably the problem. Oh, looks like I'm getting this incorrect though. plus here. What am I doing incorrect? Oh, I think this F should be over here. Oops. And this should also be on the outside of the loop too. Okay, nice, so that's correct. Submit it. Nice, so yeah, got it correct. Yeah, and so I would say this is a pretty efficient solution. I was first thinking of 2 pointers, but I did some research and then I found that the KMP algorithm would probably be more efficient in this case. And I ain't even sure exactly how 2 pointers would work. It probably could though, but just be, the runtime would be really long, I think. It wouldn't be very efficient. So in terms of evaluate, I think both space and time are O of n. As like all these, we create some new, I think the longest, the biggest base amount of space that we use in the solution is this new array, but it's based off of this like combined, and combined is based off like our input too, right? So, and then this loop for time complexity is probably our longest time complexity, but this goes off of like what combined is. So it kind of like is based on like our input as the combined is our input string plus it's the reverse of the input string. So thank you, that's my UMPIRE walkthrough for minimum characters required to make a string palindromic.